So welcome everyone to our first of the extended maths certificate deep dive sessions. We're going to have a look at a couple of key topics that us at the Maths Emporium team thought was a good place to start to showcase how we are taking those topics from GCSE, extending them a little bit further, but not touching the A-level content. So I'll be able to show you those. This is going to be really useful if these are new topics to you. Maybe you're an ECT. It might be, the first time that you're delivering these topics. So hopefully some good CPD at GCSE as well, and at A level. Or you might be a non-specialist who's being asked to deliver some of this content alongside the GCSE. Let's remind ourselves there isn't any additional kind of new content to be delivered outside of the GCSE specification. This is just extending some of those key topics that we've highlighted and listed out before in our getting ready to teach events. So the two topics we're going to look at today are the equation of a circle and the trapezium rule. So I'm very much looking forward to talking to you about some maths. But what we will do as well is through the agenda, at the start of, before we get on, I'm going to put a poll onto the screen in a second. We're going to run a second event, and we will gather the information collected in this session to help feed through. So if you are watching this recording back, this is just information that we will gather from all of the teachers attending the live session to feed in what we feel could be good topics, but we wanted you guys to have your say. So if I could ask for that poll to go live, but whilst that poll is being shared with you, I would like to, we'll have that poll up. There it is. Just pick one topic out of there that you would prefer to see, and we will pick out the top two, of course. But the agenda for this afternoon, we are going to look through a brief course review, so you can have a look at what the course actually is. Maybe you haven't attended a Getting Ready to Teach or a launch event, and you've heard about this new course and want to attend today as your first EMC session. Then we're going to split the session into half. So we'll look at equations of a circle, and then we'll look at the trapezium rule, and then I'll do a nice tour around how you can get key resources. So I know lots of teachers are asking, where can I get resources? What support is there? So we'll go through those and all of that extra support as well. So gathering data is key, isn't it, for what we want to do next. So let's get started. I know that Antoinette will remove that poll for me in a second, and we'll see the results. There we go. Wonderful. Brilliant. I wonder if linear programming definitely was a good one to pick up, and proof. Brilliant. So those of you that might be listening back, linear programming, indices, proof, solving trigonometric equations, and domain and range of functions were listed as what we thought were good topics. And it looks like linear programming and domain and range of functions are the top two. So we will do what we can with those. Proof has come in at a close third, so maybe we'll do a third session for proof and trig equations. We want to make sure you've got all of the support. So thank you for doing that. That's really helpful. Let's have a look at this course overview then. So as you may have seen, I want to make it brief because I'm aware that some of you may have attended the Getting Ready to Teach or the launch events, which of course the recordings are on the Maths Emporium, so you can have a look at those at your own leisure. But we have significant extended content in algebra. So just over 50% of the content in this course will support algebra. We know how much students struggle to really understand or master the algebraic content at that higher GCSE. I've certainly taught A-level students that just don't have the skills. They've learned by rote and they don't actually understand what it is they're doing. They don't understand why they are expanding that the three brackets, they'll know how to expand three brackets, but they couldn't sketch it for me. They don't really understand what happens if certain variables change, for example. So all of that algebra content, I think, will really help produce better ready students for A-level. However, it also will make sure that your GCSE students are better at what they're doing already. So I've talked a lot to teachers in recent weeks about raising your Progress 8. This does not count in your Progress 8 bucket collection. However, what it will do is raise your Progress 8 via the GCSE maths course, because it should improve your grades. We've got no statistics because we do have GCSE statistics, and so we wanted to avoid any overlap. We didn't want any repeated content. And you can see it under ratio and proportion. We've got the gradients and rate of change, Pythagoras theorem proof, and vectors in geometry and measure, and proving standard circle theorems, and then probability. We've got a little bit of probability, independent, dependent, and conditional. So that's just what the course entails. The number, of course, I skipped number, didn't I? But indices, we are hearing a lot of griped A-level teachers, understandably so, that are struggling with students and their index law knowledge and application, and SERDs as well. So making sure that we really extend their knowledge. Let's have a look at the course overview around the equation of a circle. So the top box you can see is the spec reference for GCSE. So equations of circles. At GCSE, students are asked to recognise and use the equation of a circle with the centre at the origin, and to find the equation of a tangent at a given point. I've also put in the EMC, so we abbreviate Extended Maths Certificate to EMC a lot. So the specification is in that left box. So recognise and use the equation of a circle. So no specification as to where that centre point will be. So it could be at the origin, it's likely to not be. Find the equation of the tangent, recognise, sketch and use. So we can see we've just extended it a little bit. The middle box, or the second text box there, is some additional guidance. So the students are being asked to understand that coordinate geometry. They're using the equation in that standard form given there, and to be able to use completing the square to find the centre and radius. And it just shows you at the end the GCSE spec reference and the A-level spec reference. To just tie all of that together, so the EMC sits between that A-level and GCSE. So here's the A-level spec point, 3.2. So we can see that we're understanding and using coordinate geometry, using the equation of a circle in that standard form. We're asking students to complete the square to find the centre and the radius. And then you've got these additional A-level contents, which of course will not appear at EMC. So you can see the significant differences between what they're being asked at GCSE and at EMC and at A-level. So we're not taking them any further into the A-level content. Let's do the same for the trapezium rule. So at the top, GCSE. So students at GCSE maths, they have to calculate or estimate the gradient of graphs and the area under, and then interpret their results in cases such as distance time or velocity time graphs, or anything with financial context. They are not required to do any calculus. And that is the same at EMC. He said GCSE again, EMC. However, the difference here is you can see in that spec reference point in the first box, very, very similar. But in the guidance here, it says that they are interpreting their rate of change by drawing and finding the gradient of and a suitable tangent to the curve. And they're also including specific use of the trapezium rule for estimating the area under. So it's taking them a little bit further in, not further on, so deeper rather than further, I should say. So using that trapezium rule, which we have confirmed will be given in the exam, so students don't need to remember the trapezium rule, but we will talk about that a little bit later. Okay. I've not put the A-level spec in there, of course, because calculus comes into play at A-level. So we are not taking students, this qualification does not take students further into A-level content. Right, let's have a look at the equation of a circle then. Love to do a bit of maths. I've been looking forward to this for a while. So GCSE, I've just taken some snips of examples. I've put the key notes at the top, what the equation of a circle looks like. We know that in all cases. A point on the circle follows the rule x squared plus y squared equals radius squared, center 0, 0, and a radius r. That's your GCSE. And so you will see questions a little bit like this. I've picked out a few from over the years, so various questions. We can see that the center is always around 0, whether you can see that algebraically or graphically. And then we take it into EMC, and we should start to see questions that look a little bit like this. You may have seen these questions already if you've looked at the sample assessment materials. They're available on the Extended Maths website and also on the Emporium. So if you haven't had a look at the sample materials yet, please do take a look. But you can see the slight difference. So we don't have a centre of at the origin in all of the cases. We do have a centre with the origin on that one on the right hand side, but we've got a point P passing through, so a little bit deeper. So that's what the questions at EMC would look like. So I'm here to just help. If this is a new topic for you or the deeper dive, let's have a look at what that looks like in particular at EMC. So this is a key slide that you might want to share with your students. So key notes, of course, f of x minus a is the translation of the graph in the x direction, and f of y minus b is the translation of the graph in the y direction. That's the key things they should be picking up at GCSE as part of their transformations of functions. There's a nice example there. I've taken an example where the center is not at the origin and a radius, and we can see how that's been plugged in, so we can see where that translation is happening. The x coordinate point is 2, so we can see x minus 2, and then we have the y coordinate minus 3, and so we have y minus -3. Use my minus and negative the right way around before Chris and Mel and Vicky tell me off. And then that's tidied up to find the equation at the end. Let's have a look at how that could look graphically. So I've got a nice example here that you will find in the worked solutions. So our lovely Mel, who's sat in the background, does some lovely work solutions for us. So this is one of the examples from the sample assessment materials. We will have brand new sample assessment materials coming out. We're trying to get them out before Christmas. But it could be just after Christmas as a late present, but more sample materials coming your way. We do also have topic tests which were released beginning of the week, end of last week, so they're on the Emporium already. So there are equations of circles topic tests. There's a QR code on the front of the topic test where students can scan and watch a video walkthrough. So lots of resources. We'll go through those at the end as well. But here's that nice example of the walked through solution. So the circle C has a center of 0, -3. And a circumference of 4 pi, and the students need to sketch the graph of C for part A. So a little bit of deduction. So using the circumference of the circle equals pi times diameter, we're given that the circumference is 4 pi, so therefore the diameter is 4. And so the radius is 2, and a lovely little sketch to show that. And then that question goes on into part B. The line L has an equation 2x minus y equals 5, and we need to find algebraically the coordinates of the points of intersection of C and L. Now, a nice diagram, students might want to put the diagram together for, for visibility. I used to say to my students all the time, if in doubt, draw it out, to give them a little hint. But first step, to be plugging in their equation from the page before. So we just go back there. They can use the information given in part A, and they will find that they've got their equation of their circle denoted as equation 1. They've been given the equation for line L. and rearrange to be in a suitable format, because we need to do some substitution here. So denoted as equation 2. And then we're going to substitute into that first equation. Lots of working out lovely algebra there. So we are given our 2x coordinates, our 2x points, and then just a substitution back into 2 to get those y coordinates. And then you have your final pair of coordinates there. So a lovely, lovely worked through example that you could give to your students that they can work through together. You could put this one up on the board for them. The resources are available on the Emporium. You can get these slides there. So that's an example of a question from the Emporium that we've put together. But don't forget, this qualification has its own textbook. It's got a brand new textbook. So let's have a look at one of the equations. There's also, I'll talk to you about the resources at the end. You can also get access to the textbook digitally via Active Hub, which I'll show you at the end. But here's another example. Of course, with any brand new qualification, the more practice and exposure to different types of questions, the better, right? For us as practitioners and teachers, making sure our students are ready for the exam and no surprises in the exam, but also that they're getting enough practice to master the topic itself. So here, one of the examples in the textbook, just in case you haven't seen that book yet, we've got example 3 I've just picked out here. So we've been given the equation, x squared minus 4x plus y squared equals 8. And they're being asked to work out the radius and the coordinates of the center of the circle. So it's not looking very standard. It's not looking very GCSE. So it's taken them a little bit deeper. And so the first thing we're going to have to do is using that equation, let's complete the square for the x terms. So that will isolate the x terms and the y terms separately, so we can then figure out the coordinates. So we are rearranging into the form. Now, what we wanted to pick up here is, yes, we should have y minus b squared in the green kind of hint box there, but we can't see, we've got the 0. So I think what the writers of the textbook have done is not put in, you know, y minus 0, but it would have been tidier to have it that way, or y minus b, at least in the standard form that we've seen in the teaching notes. But I think students and you guys as well will be able to see that they've left it in this form because there is 0 translation in that direction, and we seem to have that nicely put, don't we? I think we're almost there now, so we can say that the center for this circle is 2, 0, and the radius is root 12, which they can tidy up to be 2 root 3 if they wish. Brilliant. So that's a kind of short whistle-stop tour through equations of a circle. I'm hoping it feels a little bit clearer where the parameters are, where you go from GCSE into EMC and then on to A level. A level will be, you know, like we saw with those spec reference points earlier, asking students to be doing more things with tangents and perpendiculars, etc. So let's have a look at the trapezium rule now then. So slightly more extension going on with the trapezium rule by the use of an additional formula. So like we did just now, we've got GCSE to EMC. I've put them on the same page this time, so you can see there's a bit more information coming up on the next slide, so I didn't want to overload this one too much. So the standard GCSE questions that you can see, we've got, I think that question there says the distance of a rocket travelled. We've got distance between 2 houses. So we've got time, distance time graphs. And then they've got purple background. So there are GCSE ones. The EMC example that I've put there, so they're asking students to use the trapezium rule to find an estimate for the area of the region under the curve y equals 2 to the x. They've been given the ranges, x is 1, x is 7, and the x-axis, and they're told to use 4 strips of equal width. Now, students will be told how many strips to be using, and they must give their answer on this example to 3 significant figures. So there's a big I would say big difference. You can tell the deeper demand that's being asked of students here. But again, no brand new content for them to be learning. However, we are going to give them that trapezium rule so they can extend their understanding further, because through the powers of teaching, whichever method you choose to deliver, we've got the textbook, of course. We also, you might use all sorts of different platforms, White Rose Maths, etc. But being able to see the deduction of the formula. So this in the box at the top is what will be given in the exam in its entirety. So including all of those words, so the definitions of as well. So the trapezium rule is the area is roughly a half of H, and then all of those, however many strips they're using, all of those Y values, where H is the width of each strip. The Y's are the values of Y for each of the value of X used, and N is the number of strips with equal width. So there are the key notes that I've picked out for you, where H is the width of each strip, Y0, Y1, etc. Then the next point says about Y YN are the values for each of that Y, for each of the X's used. N is the number of the strips the area has been divided into. And then we've got X equals A and X equals B are defining those vertical boundaries, which we've been given in that previous example we've just seen. We'll have a look at that question in a bit more depth in a second. Then we have the number of X values and Y values is being one more than that, the number of strips. And then they can use the H equals B minus A over N to calculate the width of each strip. That's a lot of notes and words and explanations, but let's have a look at one of the examples. So that example that we put up just now, again from the work solutions, there is also a topic, a key topic paper on trapezium rule or areas under a curve. So do have a look at that as well. So using that trapezium rule, we've been given the boundaries, X is 1 and X is 7. We've got the curve Y equals 2X. We've been told to use 4 equal strips. So we've got, a selection here, in between range of numbers to pick and choose from. All of those figures where X is 1, X is 7, and a few in between have been plugged into Y equals 2 to the X. And we've got some nice outcomes. And then we substitute that into the formula given. So we have, if I just go back to that formula just there. So we plug that in using the values that you've been given. And we've got four outcomes, adding them in as we go. You see this? And then the total, once we've added them all together, is 197.867. And we have to give that to 3 significant figures. Just letting people have a look. This can be broken down as well a little bit more. If you were using this example in front of your students, you could take each of the 4 and show them exactly where they've come from. So using that formula, so we've got where X is 1 and where X is 2.5. So those 2 have been plugged in and multiplied by 1.5. And then the next 2, so we've got 2.5 to 4, and then we've got 4 to 5.5, and then 5.5 to 7. So that gives us those 4 equal widths. So just showing you that equation there. So don't panic, the formula is given. That's a conversation we've just been having in the team and with the writers, so they will be given. So let's have a look at the examples from the textbook. So I picked out this graphical representation of the question. So here is the graph, Y equals negative X over 5, X minus 10. and students being asked to use the trapezium rule to find an estimate of the area of the region under the curve in the region between x is 2 and x is 8, and using the three strips of equal width. So students have been told what their bandwidth is going to be. They've been told how many strips to use, not what the bandwidth is. So they're going to use that formula. H is B minus A over N. So we know that we're working between 8 and 2, and we're dividing by 3 because of the 3 strips. So it tells us that the width is going to be 2. I would adopt this method, a nice little table. The work solutions doesn't have the table, so you don't have to if you don't want to, but I think this is kind of nice and neat and tidy. So we've got between 2 and 4, 4 and 6, 6 and 8. And then those numbers are plugged into the equation of the function. And then off we go. So we've got the formula given at the top. So we're going to do a half multiplied by 2, lots of, and then those numbers are plugged in. So we've got 3.2 from where x is 2, and then 2 lots of 4.8 and 4.8, and then 3.2, adding them all together to give us 25.6 square units. Don't forget, you can access all of the additional resources. There's more themed papers as well if you want additional questions around GCSE. So if you do have students that are working on equations of circles and estimating areas under the graph at GCSE, there are themed papers in the GCSE cabinet. So if you've got, students working at a grade that you're not having them work through EMC questions, they can use those topic tests. Then your EMC students can use the EMC topic tests or topic papers to help as well. For those of you that don't have an Emporium account, it's mathsemporium.com. You just need your centre email address and your centre number, and then we'll be able to let you in where there's lots of thousands of resources. So talking of which, let's have a look at all of the resources. That's just a whistle-stop tour then around equation of a circle and trapezium rule. So we've got the examples from the textbook, examples from the work solutions for the sample assessment materials and topic tests that we've showcased, the spec references in the course scheme of work, and mappings are all there as well, so you can have a look where we may not address topics in future dives, but all of the spec references are all mapped in those documents in the Emporium as well. Let's have a look at resources, and it's really important. I want to show you where you can get all of these resources that we've been talking about. So there is a structured scheme of work, which again I've mentioned is in the Emporium, and the textbook will follow that scheme of work through the chapters and the lessons given. There are fully worked solutions and examples, lots of hints and talking points. It's a really well put together textbook, giving you all of the examples that you need, and like those little green hint boxes on the side, just step by step explanations as to where that next line of working has come from, being as communicative as possible. This really does support that independent learning element of this qualification. We're very clear that there shouldn't really be, for this level of student, there shouldn't really be any additional teaching required outside of your GCSE content time. There is just extensions which you could do. I've been speaking to some teachers who have said that they're going to do this through a drop-in lunchtime clinic once a fortnight for students that might want to come along, that have been having a look at some questions been set from the textbook and just want to drop in and speak to the teacher to make sure they're on the right track, or an after-school club, for example, but nothing outside. You shouldn't need to to have any extra teaching time outside of your GCSE, there are mixed practice chapters at the end of each chapter, so they can really get to grips with mixing it up and making sure they've mastered the content. Because some of the writers are on the examining team, we've got exam style questions, and I think that's really reassuring for teachers and students to know that there are writers that have been involved in writing exam content and the sample assessment materials. So they have that mindset of what the exam is going to look like, what the questions are going to look like. And so they're making sure that students are practicing in good preparation for those. There's problem solving and reasoning questions, which again will help them no end in their GCSE content. And the links to GCSE are really clearly signposted. There is a free chapter 1 on the website, so please do go and take a look if you want to have a flick through. But as I mentioned earlier, on Active Hub, I think it's around £100, but you can have the Essential Teaching subscription for the EMC. So it gives you that front of class book, video walkthroughs through those example questions, and they're the same approach as the free videos that we've done through the topic papers. There's a solution bank in PDF, which again supports that independent study. You can edit worksheets. So if you wanted to cut out some of the practice and only target some of the questions, and purposeful practice for each of the lessons. So there's ongoing practice there. There are Zoom, you can zoom in. The assessment library that's on Active Hub has the sample assessment materials in as well. So they're on the website, in the Emporium, and on the assessment library. And you can hide and reveal the answers, which we know teachers find really, really useful. So in addition to all of that, there are, of course, additional platforms out there that you might be using. We're not saying you must buy this textbook in order to deliver the qualification. It's a fantastic resource to have on the side. It's the same as a GCSE course. You don't have to buy one particular book in order to be successful through that course, but it's such a great resource to have. As I've mentioned, the EMC website, there are links to all of these. So once you have access to these slides, which again is on the Emporium, the link there to the EMC website has that specification. There's a course guide. There's also a particular resources guide that shows you all of the resources that we've got. The sample assessment materials are there. And as I said earlier, there will be additional sample assessment materials and lots more coming. There's a link to the website there where you can get the textbook. It's $29.99. It is now available on Amazon and other, you can buy it in other places as well, but we sell it directly at $29.99 on our website. I've spoken to you as well about that Active Hub Essential Teaching. So if you want to know more about that, there's a link there as well for you where you can have a look in the subscribing to that. I also used to use Corbett Maths a lot for the GCSE content. So if I wanted extra practice papers, now this is GCSE, so be mindful, it's not going to be EMC related, but there are practice papers by topic. So if you are teaching your GCSE and you're doing your equations of circle, origin at the center, get them doing some of those, first, really master that GCSE content and then extend them into the EMC using the EMC topic papers. The same for BBC Bite Size. So I put 2 links there on their revision platforms where you or your students can go to the equation of a circle, and remember it is for GCSE. It can be quite clunky, I think, but there can be certain nuggets. There can be certain videos some of them can be quite heavy to listen to as a student, but equations of circle, I think there was a video on there that I found quite heavy to digest, but it's additional links that you can send out to your students that they might want to engage with a little more. And there's one, I say the trapezium rule, but it's the areas under a curve. So again, taking them when you're delivering this content, I'm just very mindful all the time that you guys as teachers are delivering this to your GCSE students. So it's important that they get that key fundamental teaching first before you extend them into their extended maths certificate. What we don't want to happen is that you are stretching your higher retainers by taking them into EMC, and then they're missing that stepping stone up. So making sure that they're ready they're ready to extend once they've grasped the GCSE content first. There's a little QR code at the bottom of that screen there, so it will allow you to go straight to that resources page, and you can download that chapter of the textbook so you can have a bit more of a look at what that looks like. So please do that. So more support. We're very conscious that we want to make sure that you are feeling as prepared as you possibly can. So on the Maths Emporium, so don't forget, if you haven't got your account, get that done. It's free. It's not through EdXL online. You don't need your multi-factor authenticator to get into this one. It's a single sign-on its own. So once you're in the Emporium, that's the qualification has its own cabinet in that little orange circle there. And once you are in, I wanted to make sure that you saw the schemes of work that have been produced. 1 year scheme of work, because a lot of teachers are going to be doing this at the end of, well, halfway through the GCSE course. So it takes you, there's a year 10 and a year 11 route with the EMC. The spec references that I mentioned at the beginning. So when you open up the scheme of work or the mapping grids, everything is really clear where that spec reference is at GCSE and is at A level. We've also included the international GCSE specifications because some students may be sitting the international GCSE and also want to do EMC alongside as well. So with those schemes of work, we also have a 2-year one, which includes EMC notes and guidance on the SAMS questions, and even down to the spec points and resources that you might want to use. So there's a link at the top of this page for that. I love this one because we've taken that additional guidance further. It really does, I don't mean hold your hand through it, but it gives you additional resources and teaching points to consider when you're going from that GCSE into the extended maths. Now, I keep mentioning about topic papers. And in our topic papers, in that little cabinet you can see highlighted there are now 15 topic papers for the extended maths. 6 new ones came out just this week. So the blue ones that you can see highlighted are the ones that have come out this week. They were already expanding and factorizing polynomials, functions, areas under a curve, etc. So we've added in some more to go with them, and this is what they look like. So at the front of the paper there's a QR code. This one has got 2 QR codes, so lucky paper, but it takes them to the same place. That's just, we'll edit that, but the QR code will scan into a video where the students can watch a little learning video on how to walk through. So walk through that first question and give some scaffolding to allow students to be able to attack subsequent questions after in that paper. Here's a nice exemplar from the additional SAMs. So our chair of examiners for the extended maths certificate has taken those work solutions that have been done and annotated them with how we would expect them to be applied to the mark scheme. So these are just exemplars on a non-examined qualification so far. There's so much work gone into getting everybody ready for the first exam in the summer, making sure that everyone feels really prepared. So there's the cabinet, the exemplars cabinet in the EMC group contains those, so please do take a look at those. If you use it in PowerPoint, it means it can be used for CPD, but please, it also can be used as nice teaching and learning opportunities with your students. So let's have a look at what else is coming. So this is the timeline for everything we've got coming out for EMC and the rest of the academic year. So the additional set of sample assessment materials should be coming out before Christmas. We are very much hoping that that is signed off in the next week or so. And then into January, in the spring term, we've got another session. Thank you for all of the input on what you'd like to see in there. We will have Word versions and QLAs for those new sample assessment materials. Then we're going to produce some revision checklists. We're going into that summer series, so we'll be able to put some revision checklists together. We've also got some solutions coming with the examiner's comments, like we've just shown you on the original sample assessment materials, and we're going to do some shadow papers. So that's 3 sets of papers ready ahead of the summer. We'll do some revision and exam prep networks. I'm sure we'll have Chris and Mel deliver those, getting their students ready for their first series. And then the summer 2025 post-series support. So you become used to expecting everything that we put together for GCSE. We will do Word versions of the papers, work solutions. There will be a grade boundary document, skills maps and QLAs, exemplars and shadow papers. We are also looking at doing a mock set, but we're yet to decide how far into the course before we release that mock set. Finally, if there is anything that you need answering that we haven't answered already, Vicky and myself are here to talk to you, answer any questions. Vicky's email address is teachingmaths@pearson.com. I did mention at the top of this session that Vicky will send out emails with all of the updates. So if you're, everything's just really busy and you're not sure what's coming up in the month ahead, please do sign up for Vicky's email updates. There's a link on this slide deck. There's a sign up link at the top of the Emporium, so make sure you've got those landing in your inbox, and you can, if you want an instant response, lots of people just message me straight away on Twitter, Miss_mathsgeek. Just very quickly, people ask, where can I find this? What's the answer to this? When's this coming out? So you've got two nice, easy, quick avenues there to get a hold of both of us. If you want to email in at Teaching Maths, just let us know who you want to address it to, or both. We can share that. The last thing I want to share with you, we do have a podcast episode on everything around EMC. So there's a link at the top. So if you're, driving home later, or you're on the train, or you're going to the gym and you think, oh, I'm just listening to that EMC podcast with Grace Hatswell, who's our developer, who developed that, the qualification, please do take a listen. It talks about all of the FAQs that you might have, and plus there's a lot more other episodes as well. So for the 23rd of January, make sure you're clicking on that link there to the Professional Development Academy, so you can come and sign up for session 2 on that deep dive. And we're delighted to see you there. It looks like we have our results in, and I know that after this event you'll get there'll be a notification to do some feedback as well. So thank you for this point, up until this point. Thank you so much for all of your insights and thoughts, and we do look forward to seeing you at the next one.
I was just going to say, it's got nothing to do with the chat. I'll pass it back to you straight after. We've got 3 trialing this qualification this year, and it's 3 girls. Not that we're trying to up maths with our girls, it just happens to be they're our best mathematicians. If anyone in the session today or in the future sessions, watching this as a recording, want to get in touch on how we've done that, how we're using the qualification, and how they are absolutely cooking with their maths in their normal GCSE, in their GCSE maths, as well as this qualification. Please drop me an email, christian@justmaths.co.uk, or via Nick, via Vicky, via anyone. I'll happily get in touch and explain how we're doing it. So sorry, Vicky, back to you.
Please do go and enjoy an extra 5 minutes and the rest of your evening. And if I don't see you before, have a very, very wonderful Christmas and New Year. And we'll regroup in 2025. Thanks, everyone.